Alright guys, we're going to get back into it with 6.2. 6.2 is applications of normal distributions. Notice that we talked about normal distributions before, and we're talking about the applications of normal distributions, which just means we are going to apply what we just learned in 6.1. Okay, so it says to solve these application problems, we're going to transform the variables into a z-score. And then we're going to find the area under the curve. Okay, so in order to find a z-score, we need our z equation, which is z equals x minus x bar over s. So we should know that. We've done that before. Alright, so ideally what's going to happen is they're going to give us the missing pieces that we need in these word problems. Alright, so example 1, we're going to read it, we're going to pull out the important information, and then we're going to go from there. So it says, a survey found that an average, that women spend an average of $136.72. That's my average, which makes that my x bar. So x bar is $136.72. Then it says, assume the standard deviation is 2913. So that's my S. So I'm going to write that down, 2913. Then it says, find the percentage of women who spend less than 150. So this is what I'm looking for. Less than 150, what percent? Alright, so we're going to start with a bell curve. First step, draw a bell curve. What goes in the middle of the bell curve? Well, that's our x bar, which is our average. Well, in this case, it's not 0. It told us our average is 136.72. So I'm going to put that in the middle. And then what we're looking for is, we're looking for the percent that spend less than 150. Okay, so 150 is more than 136.72. So that means it's going to go to the right of 136.72. So somewhere over here to the right is 150. I don't quite know how far away that is, but I'm just going to guesstimate. I just know it's to the right. And then right here it says less than 150. So that should tell us which way we need to shade. For less than, numbers that are less than are to the left. So less than is to the left. To the left. Okay, so I'm going to shade to the left of 150. So what I really want to know is, what is this percentage over here that is shaded? What percentage is that? How could I find it? Well, we did to the left problems on the last section, and what to the left told us to do is we would look up our z-values, and that would give me my area or my percentage. Well, the problem is I don't have a z-value, which means I need to find it. Well, how do you find it? Well, we have our equation, x minus x bar over s. Our x value is the value we're looking at, which is 150. Our x bar is in the center right here. So I have x minus x bar, and then they gave us s. So this is what it would look like. X is 150 minus x bar, which is 136.72, over 2913. And so in order to find the z, I'm going to plug it into my calculator, which I need to pull up. Give it a second. Okay. Let's make it a little bit smaller so we can see stuff over here. Okay. So I have 150 minus 136.72, and then I'm going to divide by 2913. Okay, so this gives me, if I do it properly, minus 136.72. There we go. Divided by 2913. 0.4, and we're going to do 2 decimal places because that's what we can look up. 0.46 is what it would round up to. So this is what we're going to look up on our chart. 0.46. Okay, so on our chart, we're looking at 0.46, 0.4, all the way over to 6. It looks like it's 0.6772. 0.6772. Alright, so over here, 0.6772, that is the area to the left. Well, what did it ask us to find? Find the percentage who spend less than 150. Well, what percent would that be? 67.72%. What do? They spend less than $150. That's exactly what it was asking us to find. So all we're doing is using what we know about normal distributions to solve these problems. Alright, let's look at example 2. Alright, so it says each month the American household generates 26 pounds of newspaper. That's going to be my X bar. So what I like to do is when I find my X bar, I go ahead and fill in my normal distributions. So I'm going to go ahead and draw out my bell curves with 26 in the middle. So I'm going to draw a bell curve. 26, which is my X bar, goes in the middle. So I'm going to do that for that problem and this problem. 26 and 26. Alright, so for part A, it says we're going to look between 25 and 32. So I have to also put 25 and 32 on here. Well, 26 is in the middle. 25 is less than that, so it's going to go over here on the left. 32 is more than that, so it's going to go over here on the right. And I'm just going to kind of estimate how close I need it. So I'm going to put 25 here and 32 over here. Now I need to figure out which way do I need to shade. Well, I want to be between 25 and 32. So I'm going to shade between those two. Now, what to do? Well, for a between problem, to find the area, we had to look both of them up and subtract. So we have to look up both z's. Well, I don't have the z's. How could I find the z's? Well, I can do both of these x values. Let's look it up for 25 and 32. Okay, so we're going to find our z's. Remember, your z equation is x minus x bar. So I'm going to do 25 minus x bar is 26. 25 minus 26. For 32, it's going to be 32 minus 26. The average doesn't change. Now, in our problem, it also said assume the standard deviation is 1.5. So that's our S. It's going to go on the bottom. So x minus x bar over S. So we're going to look up at both of these. We're going to have two z-scores to look up. So let's go to our calculator. We're going to do 25 minus 26 divided by 1.5. I get negative 0.67. So that's one of them. And then I'm going to do 32 minus 26 divided by 1.5. And that gives me 4. Okay, so we can add decimal places if we want to make it 4.00. Now, don't just subtract these from each other, because if you never go to your chart, then you've done something wrong. Alright, so we're going to look these up on our chart. So I'm going to look for 4.00 on the positive side. Oh no. Look, it goes 3.49 is the biggest one. What to do? Well, if you look closely, you scroll up a little bit. If you look closely right here, it says for z values greater than 3.49, use this. So what am I going to use there? I'm going to use 0.9999. that basically is saying that 99.99% of our data is to the left of that point. Alright, so the next z-value we're looking at is on the negative side, so we have negative 0.67. Negative 0.67. Alright, so negative 0.67, scroll over here, here it is, 2.514. Alright, so that's what we're going to write down for that one, 0.2514. Alright, so for the between, what we're going to do is we're going to subtract both of these values. Alright, so we've got 0.999 and 0.2514. So we need to do the bigger one first. So that's going to be our 0.9999 minus 0.2514. So I'll go to my calculator and I will type that in, 0.999 minus 0.2514, and I get 0.7485. So what is the probability that it's between 25 and 32? That is 0.7485. Alright, so let's look at B. B is more than 27.8 pounds. So the number we're going to put on here is 27.8, which is more than 26. So it goes over here to the right, 27.8. And if I'm looking at more than 27.8, which way would I shade? Well, to the right, because the numbers that are more than would be to the right. Okay, so I'm going to shade to the right. Think back to your procedure table. What are our steps for a to the right problem? Well, for a to the right, we do 1 minus whatever we look up, which means we need to find a z-value. So we're going to plug into our z equation. X is 27.8 minus x bar, which is 26. And then we're going to put our s on the bottom, which is 1.5. So to the calculator we go. 27.8 minus 26 divided by 1.5. So our z-score for this one would be 1.2, and you can add that 0 on there. So again, do not subtract that. Make sure you go to your chart. Alright, so we're going to look up 1.20. 1.20 is right here, 0.8849. So I'm going to put that on here, 0.8849, and I can subtract that using my calculator. 1 minus 0.8849, which gives me 0.1151. But remember, if we're doing it to the right, we can also look up the negative sign of it. So instead of looking up positive 1.20, I could look up negative 1.20. Let's see what that gives me. Negative 1.20 is 0.1151, which is what we got. Okay, so that is how you do those problems. Now for the next couple of examples, I'll try and answer some of the different questions that could come up possibly. Okay, so let's look at example 3. Alright, it says Americans consume an average of 1.73 cups of coffee. Okay, so 1.73, average of that makes that our x bar. So I'm going to go ahead and draw our bell curve and put 1.73 in the middle. X bar is 1.73. Alright, what else does it tell me? Well, it tells me that it's normally distributive with a standard deviation of 0.34. So S equals 0.34. Then it tells me if 500 individuals are selected, okay, so that means that we are looking at 500 people, approximately how many of those 500 will drink less than 1 cup. So we're always looking for the less than, more than, between. That's what we're looking for. Less than, we should know, is to the left. Okay, so we're going to put 1 on here. Well, 1.73 is my average, which means 1 is to the left of that. So I'm going to put 1 over here. And I'm going to shade to the left. So this is not going to be a very large percentage. Okay, so we need to find a z-score. So find your z. So we're going to do x minus x bar. Well, our x is 1, so we're going to do 1 minus 1.73 divided by s, which would be 0.34. So on our calculator, 1 minus 1.73 divided by 0.34. And we get negative 2.15. Negative 2.15. Alright, so what are we going to do with that? We're going to look it up on our chart. Negative 2.15. Let's see if I can get this. 2.15. 0158. 0.0158. Okay, so 0.0158. Now, what does this mean? Well, that means that approximately 1.58% is over here. What did the question ask? It said if 500 individuals are selected, approximately how many will drink less than 1 cup? Well, that doesn't tell me how many drink less than 1 cup. It told me the percentage. So how can I figure out what 1.58% of 500 is? Well, the way to do that is to multiply the number of things that you have or things that you're looking at, which is 500, times that decimal, 0.0158. Okay, so when we do that, it's going to give us a number. So I'll look here, 500 times 0.0158, and we get 7.9. Now, you can't say that 7.9 people drink less than 1 cup of coffee. You have to have a whole person, right? So we're going to say approximately 8 drink less than 1 cup of coffee. Alright, so anytime it asks you for the specific number and it gives you an n, then it's just wanting you to multiply that total number times that decimal that you got there. Alright, for example, 4. Alright, this one's a little more difficult. It says to qualify for the police academy, candidates must score in the top 10%. Well, if I were to draw that on my bell curve, draw a bell curve, put our X bar in the middle like always, the top 10% would be on the very far right. And I'm kind of estimating here. That's the top 10%. So on the left, this unshaded region, what percent would be there? Well, if 10% is shaded, then 90% is not shaded. Okay, so we're going to keep reading. It says the test has a mean of 190. Okay, so 190 goes in the middle. That's our mean. The standard deviation is 20. So I'm going to write that down. Find the lowest possible score. So we're going to try and find this x. How are we going to do that? Okay, so let's think about going backwards from where we were. So normally we would start with our z equation, and then we would plug in our x and our x bar and our s. Well, we have an s, which is 20. We have an x bar, which is 190, but I don't have a z and I don't have an x. How can I find a z? Well, I would need to know the percent or the area that is to the left, because if you look at this chart, you're looking at all of these numbers represent the area to the left. Okay, so what would be the area to the left of that number? Well, that's 90%. So technically, if I change that to a decimal, it would be 0.9000. So what we're going to do is we're going to try and go backwards and try and get as close as possible on our chart to 0.9000. Alright, so I know it's on the positive side, so we can go to the positive one. Positive. Alright, so it looks like getting closer, 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 0.8980, 0.8997, that's really close. Alright, so this looks like the closest one right here, 8997. So that Z value is 1.28. 1.28. So Z equals 1.28. Alright, so I can put that in here, 1.28. And I'm looking for X, so I'll just leave that in there. Now we're going to have to do some algebra. So we're going to multiply by 20 to get rid of it on this side. Anything I do to that side, I must also do to the other side. So I'm going to do 20 times 1.28 on a calculator. And I will get 25.6. Alright, so then if I use my algebra rules, I'm going to add 190 to this side to cancel it out, which means I also need to add 190 to this side. So that would go away. And we should end up with our X value. So just to show you, we did 20 times 1.28. And we got 2.20 times 1.28. I'll get it together one of these days. 25.6. We're going to add 190 to that. And we're going to get 215.6. So that is actually the lowest score possible. That's the X value that corresponds to all of that information. Alright, so if you need to go backwards, that's how you would do that. Now there's an equation that we're going to learn that we're going to write in the next one that should clear all of that up. Okay, so instead of using all of that algebra to solve, there is a couple of problems that you're going to have to find the X value. Instead of doing all the algebra, I'm going to go ahead and give you an equation for this and what that looks like. Alright, so if I went to go and solve this, I would need to multiply this S. So we did that, Z, S, and then we added X bar plus X bar equals X. So that's the algebra we did. So instead of doing all that algebra, you could just plug in Z, S, and X bars, which in our case was 1.28. S was, what was S before? 20. And then we would have had our X bar there. Alright, so on example 5, we're going to kind of put everything together. Now, I would never give you one like example 5 on a quiz or a test or anything like that. This is just kind of to show you how far it can go. Alright, and normally I give this as a challenge problem to see if anybody can solve it without any help. But I've never actually had anybody who could solve it without any help. Alright, so we're going to read it. It says, for a medical study, a researcher wishes to select people in the middle 50%. Alright, so if this is my X bar, remember X bar is exactly in the middle. So the middle 50% would be about right here. Okay, so we're going to say this is 50% of our data. Right? which means if X bar is in the middle, and that's 50%, then X bar splits that 50% in half. So there's actually 25% right here and 25% right here. Alright, let's keep reading. It says if the mean systolic blood pressure is 120, so I'm going to put 120 right here. And the standard deviation is 8, so S equals 8. I'm going to write that down. Find the upper and lower reading. So what we're looking for is this X value here and this X value here. Now, I don't really have a whole lot of information, but I do have enough to solve it. Alright, you're like, well, I don't understand how you have enough to solve it. Well, what I need is this X value on the left and this X value on the right, which means I need this area on the left and this area right here. So we need this decimal. Well, if this is 25% and this is 25%, and X bar splits it in half, that means that half of the data is on the left and half of the data is on the right, which means this should, to the left of it, be 50%. So that would make this bottom piece here 25%, which would also make this top piece here 25%. Okay, then we go back to our chart, and our chart tells us that when we're looking at this, in order to look something up on this chart, we need the decimal for the area to the left. Okay, so for this first reading, this X1, what percentage is to the left of that? Well, that's 25%. So if I just wrote that as a decimal, that would be 0.2500. Now let's think about the second, the upper reading, over here on the right. What percentage is below that? Well, I've got 25, 25, 25. That's 75%. So that's going to be 0.7500. So what we're going to do is we're going to try and get as close as possible to 0.2500 and 0.7500 on our chart. So let's look at it. On our chart, on the positive side, we're looking for 0.7500. Well, the closest we get to it is right here, which is 0.67. Z equals 0.67. Alright, and then I'm going to go to the other side and I'm going to look for 0.2500. 0.25. Alright, this is the closest we get, 0.2514, and that's negative 0.67. Alright, so now I have a lot of information. I've got my Z's, I've got my S, I've got my X bar, which according to this is all we need. Okay, so we're going to solve for X1 and X2. We're going to use that equation up top. So X1, Z value for X1 is negative 0.67. So I'm going to write that negative 0.67. My S is 8. And then I'm going to add my X bar, which is 120. For X2, we're going to do 0.67, 8, and 120. Alright, so we're just going to have to plug it into our calculator. So we're going to do negative 0.67 times 8, and then we're going to add 120. So X1 would be 114.64. I'm going to do the same thing for X2, 0.67 times 8. That's not 8, guys. Plus 120, and we get 125.36. Now, for blood pressures, normally they're whole numbers. We're not doing decimals, so we could make this 115 and 125. So our upper and lower readings are 115 and 125. Now, again, I would never do this to you, but it is good to know, especially how to plug into these formulas like that. And if you don't understand, if that completely confused you, that's fine. I want you to focus on examples 1, 2, and 3 in this section, and you will be A-okay. So focus on examples 1, 2, and 3, and then you can use this to kind of answer any other questions you might have had if you can understand it. Hopefully that answers all of your questions.